Welcome back everybody, I'm Ashton and this is Desktop Inventions. Now today we're going to be making a digital thermometer which can read up to 4 different thermocouples at a time. And why would we make this, you ask? Well, turns out when it comes to 3D printing, temperature is very important. Just the difference of 5 to 10 degrees can be the difference in a great looking part or a spaghetti cobweb looking mess. And furthermore, we'll be using this device in the future to track the performance of different fans and hot ends and other changes we make in the future. And then I can take that data and share that back to you guys. So with that being said, let's get to the design. Okay, let's go over the hardware we're going to be needing today. So this is a K-type thermocouple here, and this is the MAX 6675, which is going to read that thermocouple. And in total, we'll be needing 4 of these. And we'll be using an Arduino Nano to read the temperatures from our 4 thermocouples. I happen to have the pins soldered on the top side of this one. And finally, we'll have our LCD monitor. This is an I2C version, so it has this board soldered on the back, so you only need 4 pins to control it. So let's start to get these hooked together. First, we'll start with just the thermocouple, and then later we'll add the LCD to that, and we'll go from there. And here we'll be hooking the thermocouple to the MAX 6675. Very important, red goes to positive, blue goes to negative. Then we'll just be using some jumper wires to hook it up to the Arduino. You can follow this diagram here, which will go along with the example code provided. With everything hooked up, let's get some power to the Arduino board. So here's the example code to read 1 thermocouple. I've got the link to that in the description down below. And for now, we'll just be using the serial monitor in the corner to read the temperature values. And now I'm going to grab the thermocouple and see if the temperature increases. But wait, the temperature is actually decreasing. Let's take a look. Turns out I had the red and blue wires hooked up backwards. Again, red should be positive and blue should be negative. And once we got those swapped around, everything was working fine. Now let's try the ice water test. This ice water should be 0 degrees Celsius. So we're going to take this thermocouple and put it in there and see what it says. The thermocouple here was very slow to stabilize, took 2 or 3 minutes, and finally stabilized around 5 or 6 degrees. So let's try that again, except this time I took and ripped the metal tip off, so now the thermocouple is much quicker to react. So now I'll perform the same ice water test, and you can see it instantly drops to about 3 degrees once I put it in the ice water. And now on to the next phase of testing. I have the second thermocouple hooked up to the Arduino here, and I also have the LCD screen hooked up as well. So let's go ahead and get this powered up and see how the LCD screen is working. You can see both temperatures listed here as T1 and T2 on the display. And since nobody wants a bunch of loose electronics and wires laying around, we 3D printed an enclosure here. So here's the base of the enclosure. I've got this designed up to house all the electronics. Very simple here, almost no support material. I just decided to print with a raft to play it safe on this print. And then we have our cover, the top side. This one is no support and I did not go with a raft. I want a little bit nicer surface finish there. And to start out the assembly, we'll be attaching this thermocouple sensor, the MAX 6675. We'll be attaching it in this first position with an M4 screw. Yep, my screw is a little bit long. It's protruding out the bottom here. I would recommend a M4 by 5 or 6 would be a lot better. And now we'll go ahead and assemble the rest of these. Ah, drat. So a good tip if you want your screw to stick to your screwdriver, but it's not magnetic, you can always take a magnet and attach it to your screwdriver, and now your screw will stay on there. And it's also good for holding your extra screws. There we go, got our 4 sensors mounted up. And next should be the Arduino. So that'll mount right here. Alright, and now to mount the Arduino in place, and wow, that's a small screw. So I need a M1.5 screw to mount this, and it's one of those things you either have 140,000 of them or you have 0, and right now I have 0, so I'm going to go scavenge some electronics and see if we can find something. All right, so after some digging, I managed to find some M1 little tiny screws. They're a little bit small for this, but I think they'll work. You can see they're just big enough not to pull through that hole. All right, so the holes are a little bit too big, so we're gonna use just a little bit of persuasion. We're going to deform them a little bit smaller. All right, now that our screws are gripping and the Arduino's in place, next will be the LCD screen. All right, now to install the LCD, and this is the part where things start to go wrong. So we have this nice connector on the back that's supposed to drop into this slot here. And that fits like a charm, fits perfect. But the problem is, this is the top of the display. So all the text is gonna be upside down. So actually, we need to flip it like this. So the connector is gonna be over here. So that's gonna be a problem with our wires. So I'm gonna go ahead and see if I can bend this connector over the other way and see if we can route the wires through this area over here. All right, there's the bent pins. I know it looks pretty ugly, but bear with me. All right, so there's the wires on there. It appears like it's going to fit, so let's try it. There we go, no problem. So we're facing a rather difficult problem here. We have 4 of these sensors. We have 1 Arduino and 1 LCD display, and they all have power pins and they all have ground pins. So that's 6 wires we have to connect together and 5 that need to connect to the Arduino. But we only have 1 pin for power and ground. So what we're going to try and do is take 6 of these wires. We have 3 here and 3 here, and use this wire nut, this little wire nut that was given to me, or came with the Noctua fans. So we've got 3 twisted together here, 3 here. We're gonna try and put it in the 2 openings for this wire nut and smash this wire nut and see if it works. Oh, there we go. I think it worked. And there's our hexa connector in place. So we've got it connected to all 4 here, up here, and then 1 going up to our LCD. So now let's do that again for the power. All right, now we've got our second 6-way connector there, and we've got our power distribution hooked up and figured out. Now we can go ahead and connect the LCD. Okay, so before we get all the sensors hooked up, I've hooked up just the first one to the Arduino. So we're going to connect the thermocouple to it, red and blue, and see if that works. All right, now we've got the board officially lit up and working. Got our thermocouple and the board is working. I can pinch this. We can watch the temperature rise. So everything's working. Now I'll have to get the other 4 hooked up and wired up. All right, I've got all 4 thermocouples hooked up, and we can see reading 3 of the 4 temperatures. This one says not available, which is a pretty cool function. If this is not hooked up, it won't show the temperature reading. So if we connect this there, we can see all 4 of them. Pretty cool. And now with everything hooked up and working, it's time for the most satisfying part, and that is to install the cover. And now we can flip it over to the back side and install the 4 screws. All right, now that we've got everything together and running, I'm curious to see what happens with temperature 1 and temperature 2 if they go over 100 degrees. You can see right here it's running out of room. It'll start running into the T. So Here is T1, and here is some fire, so let's see what happens. Oh, it just knocks off the last decimal place. Alright, now let's do a test to dunk all 4 thermocouples into some ice water. See how consistent they are. And looks like they're all pretty close, right a few degrees above 0. Now let's do the same test here. We're going to put these thermocouples in some boiling water. They all are very close to 100, which is what it should be. Alright, now we have the sensors hooked up to the 3D printer. I have them on the bed here, one at temperature 1 in the middle, the bottom, the right, and the top. So we're going to go ahead and preheat the bed and see if these temperatures match the bed temperature. The bed is heating to 55 degrees. And now we can see all the bed temperatures stabilizing just a few degrees below that 55 degree mark. And this makes sense because there's an extra magnetic sheet between the heated bed and the sensors. And that's as far as we're going to take this build today. I do have some ideas in the future to add a micro SD card slot to the side here so we can turn it into a full data logger. But if you enjoyed this build, leave a like or comment down below. I do read and respond to all your comments. And until then, we'll see you next time at Desktop Inventions.